you know, different tools that can be used by us in respect of working with understanding this system programming. I assume I'm audible.
Yes, sir.
Yes, sir.
Okay, okay, good. So with assumption that each one of you is having laptop or desktop along with you, like while you are attending this class, it would be better always now further. Okay, because whatever I would be doing here, you are going to do that. So we are going to make use of an assembler called NASM. So you have to install this by writing apt-get install NASM. Okay, what are the version that you have? So this would be a network assembler, which is portable x86 assembler. Okay, now while we are working with this, ultimately our target is what? To learn assembler, we are going to make use of assembler. So when I tell you something theoretically, I would be showing you practically. And if I show practically, I will give you theoretical base for that practical approach. Fine. So when we talked about say the code, which was an executable, correct? So we had a dot out. So now when my program, this a dot out, gets executed, okay, at from the shell prompt by user, what happens is that program would be loaded in memory and it would be given some space in memory, which is called as process address space. Now what happens there is like you would be executing that code. Now if I think of my program is loaded the way that I showed you earlier. Suppose this is a space. This I took as a code, correct? This was my code in, if you recall, previous session. Now actually this was the linked code afterwards. What is the code that was combined because of linking main ABC and PQR? Now if I see this code, now this code would be part of process. So let me, this is not available for us right now. Okay. Ultimately, we don't have any idea about what you can call it as what would be there, what would not be there, and so on. Fine. Now, some part of it would be given to what you call as data section. This would be your data section. Then code would be there and some amount of storage. Now, like organization may differ. Okay. For these all in organization, in the sense of like how, where and how it would be. So now let us say this is my code where this is part of data. OK, this one is my code. There would be some additional memory area which would be given, and this would be for heap. I assume you must have heard a terminology called heap. Have you heard heap? What is heap? Amol, what is heap? HEAP. Have you heard this term? Heap? Anybody from your class? Have you heard about heap?
Yes, sir.
Okay, what exactly it is?
It is used for sorting the elements in a list or
Okay,
an
so
array.
you are talking about heap sort. No, then in general, let us not talk about data structure. Okay, now have you heard about heap? So I hope you must have used something called as what you say dynamic memory allocation. Am I right? Have you used malloc?
Yes.
Have you used malloc?
Yes,
From
sir.
where the memory is allocated? Now see, like while I was talking about process address space, this is what I do see. Okay, 1 minute, you will see that screen. Yeah. Can you see this? So though I'm referring to say, for example, one of the website. So there would be your program and data. there would be stack information available, there will be heap available. And if you recall, when we saw the file, our executable file, okay, at that time we exactly saw that there is additional code added there, which was not written by us, but definitely it would be part. So kernel and global data, these would be added by the system itself. If what would be my contribution in this process address space, the program that I wrote and the data that I declared, only these things. The rest of the things are added by my linker so as to create it as an executable. Now, when I do say this, ultimately, I need to exactly know what are the code that I wrote, how much contribution was there from my side. Okay, so let us see this particular command or utility called size. So list section sizes and total size of a file. Fine. Now, how exactly we do this? So you write size out. So your text contributed to 1540 bytes. Your data contributed to 300 bytes. This BSS block starting with symbol would be having what you can call it as 8 bytes. And total size of the file was 184 byte, 1848 byte. Then in hex it is 738. And what is the file name? This. So this size command would be telling us that. Now whenever I do write an assembly code, I have to make use of sections. So what exactly those sections would be? So let me see. So when it said like on the output of size with the output of size, we saw there would be text, data, BSS. This would be there. So this would be called as code section or text section. This would be called as data section. This would be called as BSS section. Though both of them contribute in memory as an a data only. But while writing the code, we have to specifically differentiate which would be initialized and which one not be initialized. Correct. Now how exactly you do? So as I said, we would be making use of following sections. So sections in assembly code. So you would be writing data. So which will be containing initialized data elements. BSS uninitialized data elements. There would be text. This would be the code you want to execute. Now, if you recall, we talked about RO data also. Okay, so RO data. Sometimes you write, sometimes you don't write. RO data. So this would be read-only data elements. You cannot write or you cannot override that value. So mainly, like your code would be contributing this. Now, how exactly your code would be? So your code would be having this form: label colon. This is optional. So I'm writing this in square bracket so as to say that it is optional. Then you will have mnemonic or opcode. Correct. Then optionally you will have OPND operand 1. You may have OPND 2. Sometimes you have both, sometimes you have only one. Fine. And lastly, you will have comment. Now comment would be starting with semicolon. So your code would be containing these things. So how your code will look like? Say for example, if label is there, label means identifier, which would be part of say function. So suppose if my function name is ABC, then I will have like this. So my instruction would be say for example move. This is a mnemonic. So I may write EX, ABX. Now these would be treated as my operands. Now these operands can be registers, memory, or immediate values. So for example, in CO course, you must have heard or learned something called as addressing modes. Have you heard about addressing modes?
Yes, sir.
Yes, sir.
Okay, so like addressing modes would be contributing with what, or would be decided through what exactly you are having as an operand, and depending upon that, the instructions would be decided. What would be the instruction? Correct. So now when we deal with such kind of aspect, ultimately, how my code would be. So there is a particular format to be followed. Like when you were taught about C program, you were told you have to write main. Okay, then you have to write, say for example, brackets, pair of brackets, round parenthesis. Okay, then it may contain optionally integer argc, char double star argv, and so on. Now, when we do talk about this format, ultimately, like let me show you one important thing. Okay, when we write any C code, say for example, today bio3.c, I write my code like this. So I assume most of you must have written these ones, correct? Am I right? So your main would be also having, say, parameters or as a function. So print f %d argc. So let me write here number of arguments are. Now for I equal to 0, I less than argc, I plus plus integer I, printf argc of %d is %s slash n slash n I comma argv of I. Let us save this. Let us create an executable. Fine, because I haven't declared this here. Okay, number of arguments are 1. First argument is ./.out. Number of arguments are 2. First argument is ./.out. Second argument is 1. Number of arguments are 2. First argument is ./.out and second argument is India. Now, when we fired some commands from shell prompt, you must have seen that it is making use of those parameters. Like for example, when I use ls-ltr, so it identified this as an argument for this file, for this execution of this command, right, which itself is a binary file or executable file. Now, when I do deal with this thing, this kind of aspects, so do I have to what you can call it, really see where exactly my code is getting executed? So I hope this is what was told to you, like whenever you are writing main function, if at all you want to make use of arguments for, or if you at all you want parameters for, say main, there would be only 2 arguments, argc and argv. But this is not the case. There are totally 3 arguments. Okay, in standard C. Okay, the other parameter is **envp. Okay, now here let us do this. So So let me write here 12. Okay, randomly I am picking this, and here I am writing ENVP. So these both ENVP and ARGV are array of strings. So argument values would be stored into ARGV, which is array of strings. So that's why ARGV of 0 is a dot out, ARGV of 1 is whatever you mention, and so on. Correct. So let us try to execute this. So you will get warning because we haven't included that stdio.h. Fine. Now let me execute this. Nitin P Patil PUCSD, employee number 9168, mobile number is this. Done. Now see, number of arguments are 7. 1, 2, 3, 4, 5, 6, 7. Correct? Now you got this 7. So a dot out 1, 2, 3, 4, 5, 6. Now see these values. These are internally added by the system for environment parameters. Wherever my code is going to get executed, what would be values for it? Now from where this information came? Rather, even if I don't write that dot slash a dot out, will I not be able to make you see these values? Definitely not. But whenever you are using it, you would be able to see that. But even if you are not using it, these are associated with your code, hidden information. Some information which is hidden from you. It will let you know on which cell you are executing that code, what was the path, everything would be there. So if I increase that, say, count there from say 12 to 20. Let me execute this only. Now see, we can see so many values. So it is telling me which code, this code, from which directory this code is getting executed. So is it going to end here? So though I have showed here ARGV, let me make the change in the code. It should have been ENVP na? Here to show that. Okay, let us add, let us make it 40. See, so many values are there which we never have worried about. There are like these are the parameters which were added there. Like it even is telling me that who is the user who is executing that code. Now the standard, when standard C came into picture, like when I say standard, I meant to say the one who gave Dennis Ritchie, when he gave the C compiler to the world, he actually added these 3 parameters. But this third parameter was never been used by general programmers. This was meant for mainly the system programmers. If they wish to see, if they wish to set some values with respect to environment, how can they do so? Okay, so if I write, say for example, P, let us see if we can get values. So see ENVP 0, 1, 2, 3, 4, 5, 6, 7. These are the color settings. I disabled colors on my screen, like on my screen. That's why it is not showing me this ultimately. Right? Some values might be getting repeated later. Here, for example, you saw username Nitin. Correct? Here below you will see only user Nitin. So they might be having different, they might be referred for some different purposes, though they look to be same. So what happens if I write that as 60? Now suppose if I say from Monday I will be taking physical classes. Let us assume this. Now your environment parameters, you will try to see the values. Okay, what would be your environment parameters? Okay, where I'm going to stay. So if at all today only he is telling that you have to be here on Monday, what about my tickets? Am I going to get them? How exactly I'm going to reach there? Now see, after 50, it is giving me error. So probably like 49 parameters are there. 49 parameters are there right now, which are set. These are the values taken for my code. These are the values taken for my code to create that environment. Now, when we say this, ultimately, how exactly this decision would be made by the system, and that's what is happening when we say process address space. These values are added somewhere. So, like in the case when I write my code, how my code will look like? My code would be divided. Now, no matter whether in which language you are writing, when it gets translated to machine language, ultimately in between somewhere assembly plays an important role. So your code would be having this form. So say for example, section dot data, you would be seeing declaratives. So for example, variable name is var1. If it is integer, a byte, single character, so then you write db, define byte. You say 1. That means what? This var1 will have value as 1. This var1, if at all I want to give a character, I can write this. Okay. So var2, say db, I want a string here. I also can do this. If I want var3 as an integer, then I will write this. So that value would be defined double. So before that there is, okay, one thing I missed. So this would be a byte. Correct? Here byte would be defined, but value would be of length 6. Defined word. So this will have say VD, for example, value. So 2 bytes. That means 16 bits. Correct? Third declarative is DD, define double. This is 4 bytes. There is something more which we may not address, but I want to let you know. DQ, 8 bytes. So this value 10 would be stored in 4 bytes. In this case, the value 10 would be stored in 8 bytes. See if I have to see another one. So where 6, for example, I will be using DT. So this would be 10 bytes. 10 T means 10 bytes. So these are the declaratives that I can see: define byte, define word, define quad, define double, define 10. Now this would be for data which you want to initialize. Now in C code, when you write integer C, what is your assumption here? What is your assumption here? Yes.
DD.
No. I mean to say, like, what is your assumption in integer C? Like, what do you assume? Now, let us not talk about this declarative, about declarative. I want something more than this. Like, with assumption, suppose you don't know assembly now. Whatever I told you right now earlier is not known to you. What would be your assumption?
C is a variable of type integer.
Very good. Okay, C is a variable of type integer. Next. Good. Like you could reach to what I was expecting, but it was partial. Next.
We get the memory of 4 bytes.
Very good. C would be taking 4 bytes. Is it defined? Integers is defined here? No, it is declared. Defined means value is added there or not. It is declared. Integer C. Have you declared a variable? Yes, I have. It's C. Type variable name is C. I have declared it, but I haven't defined it. So whenever I write integer c equal to 10, then I have, okay, let me take this d. Then I can say I have declared and defined a value. So that's why this define, this is initialization. This is like var1 equal to c, var3 equal to vd, var4 equal to 10, var5 equal to 10, var6 equal to 10. Though meaning is different at some point of time or any point of time. But this is declared and this is defined. Please understand this. This is declared and this is defined. Declaration and definition. Now, if at all I have to, if I don't have anything defined, that means it would be what? Uninitialized. Correct. So in this case, I can say when it is declared, most of the time it is uninitialized. And this is initialized. So this will go to data. This will go to BSS. Now, how do I write this? Now, while I asked what exactly it means to you when you write integer C. So you said it would be a variable with name C of type integer, which will contribute to, like, which will require 4 bytes to store. Correct. So how exactly you are going to write that? So you're okay. By the way, this example I gave only to show you this. So it is not part of section.data. Next thing is section.bss. So you write a similar thing. Say for example, names might differ, but let me use var1. Suppose I want it to hold one character value, char ch, which is not initialized by you. Char ch not initialized. How will you write this? So you write reserve byte. How many bytes? 1. Char ch. Integer a of 10. So suppose var2. So you write reserve double. When I say integer a of 10, how many bytes would be reserved? How many bytes will be reserved?
10 bytes.
When I write integer a of 10, see, before while you said for an integer, it will take 4 bytes, correct? If I have integer a of 10, how many bytes would be? It is array now, correct? Yes?
40.
40, correct. How many bytes? You say 40. So if at all I have to write, so I'm not going to write, like if I write it as reserve byte 40, then it's okay. But if I have to, now this would be treated as character a of 40. But I wanted it as what? Integer a of 40. So I will write it like this, raise d 10. Reserve double, how many? 10. Am I right? Correct? That's how you would be defining this. So if at all, like when I say this, ultimately 40 bytes would be reserved. But values would be of type integer. Integer I meant to say double type. Correct? Now if you write var 4 raise say q raise w 10. Now how many bytes it will save or it will reserve? When we said word, correct? Define word means 2 bytes, but to store this value, ultimately you will require this value would be stored in a 2 byte. But when I write reserved word 10, that means 10 multiplied by 2. That is 20 bytes. In this case, it is 10 multiplied by 4, 40 bytes. Correct? Now, if I write raise q, where 5, raise q 10, what would be assumption? Now, how many bytes?
80.
80.
80, correct. One quad is 8, so 80. If I write var 6 raise t 10.
100.
100.
100.
Very good. Now you are in a position to understand this step. Okay. So like see, when we start learning programming languages, we were taught first what are the different types. See, like even we do specifically differentiate ourselves. First we say man, okay, or human. When we say human, then we categorize man and woman. If I have to compare myself with some other category, so I do say, okay, I'm a human. That individual is an animal. That individual is, say, not a human. Okay, so I categorized it. So ultimately, like at some point of time, would be only saying there is a soul. Okay, let us enter into that area. So everything would be having some say some soul kind of aspect, but all of them are differentiated with respect to their properties. So on machine level, you don't have anything called types. You only have how many do you require bytes. So 1 byte, 2 byte, 3 byte, 4 byte, 10 byte, 100 byte, 1000 byte, million of bytes. Yes, that is possible. But everything would be dropped down to byte. Now you define your variable name in such a manner like integer my array. It doesn't have any value. I mean to say operating system will not store its information. What is my array? It would be for you only. My array would be replaced by address in memory. Now let me show you. Okay, let me go back to this a dot out that you had earlier. So I'm see when we write obj dump dash d a dot out pipeless. So this is my code. At least some things I can read. Correct? This should be multiplication. This is XOR. This is addition. This is addition. This is addition. This is increment. This is decrement. But if I write it as this, now you would not be in a position to tell what exactly these things represent. Okay, one can say this is address, but we are not sure now what exactly they are representing. This group of 4 bytes are representing us. Group of 4 digits or digits, let me say, not bytes. Group of 4 digits. What exactly they are trying to tell me? So each digit is representing 4 bits. Each digit here, like this 0, like for example, this 3 here is contributed with 4 binary positions. Four binary positions means digit position I meant to say. So you are going to write it like this 0 1 1 0. Will it be this? No, actually it would be 0 0 1 1. This would be 3 for you. 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. So at max, what you can have is number is F 1 1 1 1. That is F. Correct? Correct? So like when we deal with our code, if I see this line by line, where do I see my data defined there? Section dot data. Do I see that here anywhere? No. Nothing will tell me where is your data and where exactly your code is. Until and unless you would be able to decrypt this thing. Can you decrypt this? There are some stars added. They must be contributing to something. Separation probably. At some point of time. But where exactly my main is? It would be difficult for me to find main here. Now if I see this obj dump output, then I definitely can see main. Now my main would be, yeah, I can see this main here. But in the code that I saw earlier, it was not very easy for me. So if I talk about this 11 CD, if can I get that 11 CD here? Probably somewhere here within these two lines, I can say my main is starting. So for my first line of main, okay, if I go to 11 CD, yeah, next line. It is F30F1EFB. 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 Let us see this. Can you see that? Can you see somewhere that part? C0, C1, C2, C3, C4, C5, C6, C7, C8, C9, CA, CB, CC, CD, CE, CF. That's why D0. Where is my CD? It is very difficult for us to really find out because this was at memory level and I may not be able to find exactly my code in this case. And our target is what? See, generally, whenever you're taught assembler, rather, so some of you did a systems programming course in your bachelor's. So you must be told like what exactly you are going to write. You will be given assembly code. You have to generate object code. No, our target definitely part of target would be that. But our target would be what? If I am given object code, can I conclude saying this is my assembly code? Correct. So now suppose like if I see this output, I will not show you this part. 1 minute. I will show only this part to you. पता नहीं है, वो जा नहीं रहा है. Okay. Let me do this way. I will only show you this part. Can you tell me which instructions are there when you write 2F, when you write 6C, when you write 69, 6B, 62? So if I am given this, we are actually doing reverse of assembly process. This is what we got because of assembly process, because of translation. So now we have to understand important part of this translator. Translators would be taking as an input a source code written in some language and would be converted to the desired language. Always it would not be what you call as object code. It could be anything like what we saw was with C. We give C code to preprocessor code. It gives you dot preprocessed file dot I. Dot I would be taken, would be converted to dot O. Dot O would be converted to, sorry, dot I would be converted to dot S. Dot S would be converted to dot O. Dot O would be converted to executable. This is the whole path that we saw of the translation process. So at each and every place or each and every particular stoppage where some other program would be coming into picture to get you through the whole translation process. Each one would be having its own importance. Each one is your important system program at that stage. Correct? So now like we saw that this is how we are going to declare section.data. This is how we are going to declare with section.text. What happens later? Now I would be having section.ro data, which I may or may not use, but let me use this ro data. Now how this ro data would be, you would be using this dbdd only, dbwdq for everything which is constant. So let us say I want to display a message in printf. Suppose that message is like this. Today I will end my class at 10:30. This is what I want to print on the screen using printf statement. So I have to write like this. So until unless I myself make this change, make the change in this text, will this be automatically updated? Will this be automatically updated? No. This should be stored as a constant value. So that's why it is read only data. So whenever you are having this, so it is not necessary that you should make use of arrow data. Even this can be written in dot data too. But internally it would be added into arrow data internally, which we can see later. But whatever is shown to you as a user when you are translating the code would be shown what you are or what you should see only. Everything would not be shown the way it would be. Say for example, when I write obj dump, okay, this command output that we tried. So some point of time you will see 3 dots are added there. Say for example like this. This information that what it is saying, this information I cannot show you because it is limited to the machine, not available for user to understand. Not available for users to understand. Correct? And this is how rather these 3 sections when we said RO data, take sorry BSS and data would be added. Now most important section would be section.text. Now as we are using assembler which is NASM, would be using linker at GCC. Like GCC's part would be used as a linker because we do have C compiler installed on most of our machines. We can use LD as a linker there. But as I'm making use of NASM, so to make my life simple, to make your life simple, I would be using GCC at the time of linking. So I always, my text should always contain this. And now my code will start. Every code you will have this thing. Section.text global main. Now if at all I wish to make use of a function like printf, I will write it here as extern printf. Extern canf, extern abc. How do we make use of such kind of functions there? Through extern. Sometimes it may be referred to a variable too. Like you must have, most of you must have used extern, correct? In your C code. What does extern means for you? What does extern mean for you? Extern means a variable or some identifier you referring to is not defined in the current file. It is defined in a file which would be referred or used at the time of linking. At the time of linking. Correct? Is that okay?
Yes, sir.
Fine. So let us try writing a simple code, and then like we would be writing, we would be saying what exactly is to be done. So I will write simple code today. Okay, let me first send this file to you. Control S. So okay, I hope you must have received that file at your end. See, yeah. Received? Yes. So let me write a simple code now. So I will be writing my code with file name to be extension as ASM. So say pgm1.asm. So as I said, section dot let me write raw data. So msg, this is my first try to use assembler and see the execution. Now generally you write /n, correct? /n would be shown like this, /10, and if you want end of line, you write 0. Section dot text global main. Now you have to make use of a printf function. So extern printf. So you write what is to be printed, push msg, call function, because you are calling a function, correct? So that's why you have to push parameters on through the stack, and from there the parameters would be picked and the function would be executed. Now when it returns back, whatever was pushed in the memory or stack should be removed from stack. So what you have to write it here is you have to write always this instruction. So how many push are there? Now how many push instructions you see there?
1.
1. So it should contribute to 4 bytes. So if you have 2, then you should write 8. If you have 3 push before call, you will write 12 and so on. Fine. Let us save this code. Now how exactly you are going to translate? nasm-f elf32 elf32, the way that we write m32 -m32 to generate object code with machine instruction set to be 32-bit instruction set. That's why I'm writing -f-elf. That means file format is elf with 32 bits. Now you write your program name. So I think, yeah, program 1.a. So what happens is it generates an object code for you, pgm.o. Can you see it below? So if I write file pgm.o, it will let you know 32-bit LSB relocatable, not stripped. OK, if I try to see this obj dump -d pgm1.o, this is how your code is. This is your main. Put 00, call 6. Correct. So if I write less, this is your msg. See, I declared msg as a variable, but still what exactly it did, see how the translation was done internally. It is very difficult to understand. Like even if I write a variable which would be holding strings, it is showing me this. OK, let us, we'll work out what exactly is. Now my section.text is there. Can you see this section.text? There is a main. Main is given a call. OK, main is calling function called printf, and then we are adding ESP4. OK, so let us create an executable. So how exactly we created object code? So we wrote this nasm-f-elf32 program name.asm. Then you write gcc-m32 pgm1.o. Now you should see an executable created below. So if I write ./a.out, this is my first try to use assembler and see the execution. Correct. Now what happens if I don't write, say that add esp comma 4? Sometimes I may see that my code is getting executed. So I'm adding this comment. I'm adding that statement in comment window. Let me translate. nasm link gcc. Can you see segmentation fault? It is because you created garbage in the system by pushing and you haven't cleared that garbage. It is your mistake. That's why it says first clear that. And that's the reason why do we write this. add ESP comma 4. Is that fine? See this code, how exactly we wrote that code. Now suppose if I want to print a value, if I want to make use of scanf function to read the value. So you write extern scanf. Now you have to read the value, correct? So what will you write in scanf function? Message. So this is a message 1 dB. You write only %d and you say 0/0 to end with. Now, as you are going to write scanf like this, say for example, let me write this scanf %d %a. Now we have to give this call to that function like this. So how many things are included here? One is this %d, which we added here, correct? Which we added here. And we have variable called a. So now this a is not initialized one. That's why we will write it into BSS. So how will you write this? A raised d 1. Okay. Now let me write that call function. So push msg 1. Okay. Call scanf. Now how many parameters this scanf is having? 2. How many parameters are there for scanf? 2. In this case, my printf was printf this string. Only this one was there. Now my scanf had a variable as well as the message. So I will write it like this. So first, what is to be pushed from right to left? So you write push A. How many push are now for scanf?
2.
So 4 multiplied by 2. So you write add ESP comma 8. Okay, now we have to print it. So how will you print it? How will you write printf statement? Your printf would be something like this. Printf, suppose value is %d a. Am I right? Correct? Now, when you say ampersand, what exactly ampersand means to you? What exactly ampersand means to you? Yes. What exactly is ampersand means to you?
Integer.
Arey Baba, hey, ampersand. What is ampersand?
Address of a.
Very good.
Address.
So now you have two notations. One is ampersand, which is address. What is star in C?
Location.
Pointer.
Value at. You are talking about value at that whatever you are writing there. So if I write star A, that means what? Value at that A, address A. Now, if I write here A, like if let me write this whole thing as it is. Now I have MSG2. Let me delete this. I have MSG2. I have printf. Save this. Let us translate. Let us assemble and let us execute. Now it is asking for input. Okay, let me give 40. What it printed? Address of that variable. This 32-bit address shown in decimal. If I want to display it as a value, then I have to what you can call it as typecasting karte hai na, kind of. So I have to write it like not exactly typecasting, but I have to tell how many bytes it is going to pick. So I will write here d word of this. So value at that address, which would be a double word. Pick that and use it in a printf. So now let us do this. NASM GCC. Now 40. Now value is 40. Is that fine? Are you with me? So how the code was?
Yes.
Let me show you that code. This was my code. RO data वो message था जो printf वाला आ गया. Correct. Then we had MHG1, MHG2. Okay. MHG1 we used for this %d. MHG2 we used for printf. Yeah, we haven't used this, but I'm only showing you what is meaning of this. So when we write with scanf, you simply will write A. That means it will be taking this as an address. Correct. And if I want to print as a value, I have to write this D word. Correct. Is that fine? Okay. So try these things. I'm adding this program too for your reference. Try this one on your laptop. If you know assembly code, better assembly language, you can make use of what you can call it as. I'm adding both of these codes for your reference. You can try writing them. So I'm not expecting you to know this, but at least few things. I hope those who did CS, BSc CS, they must had something in electronics course about this assembly programming. And even if it is not, don't worry, we'll work out. Fine. So work with these sample codes which I have added. Try it, see what problems you are facing at your end, and probably let me know in the next session that we'll be conducting. Okay. Fine.